How are you, my student? Welcome to our maths lesson today. Our topic is differentiation. Differentiation. In the previous lesson, we were looking at curve sketching. And we said that whenever you want to sketch a curve, you can do it even on a plain paper, and there are steps that one needs to follow to be able to sketch a curve given the equation. So when you are given the equation of the curve and you are told to sketch, you need to get the intercepts. You need to get the intercepts, that is the y and the x intercepts. Then number 2, you also need to determine the stationary point. Get the stationary point. It can be 1, it can be more than 1. So get the stationary points. That is, now you get the coordinate for the stationary points. Then you also need, after getting the stationary point, to note or to determine the nature of the stationary point. The nature of the stationary point or the points. The nature here simply refers to whether it is a maximum, whether it is a minimum, or whether it is a point of inflection. So you get the nature, and then these 3 will guide you in sketching the curve. The intercept, you have the intercept, you have the stationary points, and then you know about that stationary point, whether it is a maximum, a minimum, or a point of inflection. And all this we have covered: how to get the intercepts, how to get the stationary points, and also how to get the nature, or to tell the nature of the stationary point. So in this lesson, we are going to look at applications. We are now almost done with this topic. So we want to look at the applications of differentiation, applications of differentiation in calculations of distance or displacement. We are going to use it to calculate the displacement. We are going to use displacement or distance because they mean the same, only that for the displacement shows even the direction. So we'll use it to calculate displacement, velocity. We'll calculate the velocity, and finally we'll also be in a position to calculate the acceleration. So we are looking at the applications of differentiation in calculations of displacement, velocity, and acceleration. Displacement, velocity, and acceleration. And we are going to start with the first one, that is displacement. We start with displacement. Displacement. This is direct when it comes to calculation number 1 of displacement. I want us to consider a body that travels a distance s. Consider the following. Consider a body. Let's say we can talk of a car. Consider a car that moves a distance, it travels a distance s meters, which travels a distance s meters from a fixed point, in time, the time t seconds, and it's given in the following equation. Consider a car moving at distance s meters from a fixed point, time t seconds, and is given by this equation, and the equation is s is equal to 2t squared plus t. That is the equation. You are considering a body that is moving a distance s meters. So this s stands for the distance or the displacement. then the t is the time. And then it is given by this equation. So we are now told calculate the distance covered, when t is equal to 1 second. When time is equal to 1 second. So we have been given the equation that connects the distance and the time, and then we are told to calculate the distance that is covered at the point where t is equal to 1 second. So we simply come, and because we have the equation for distance, because this is the distance, and here we are told to calculate the distance covered when the time is 1 second. So we have the equation for distance, which is s is equal to 2t squared plus t. And therefore, we need to come and substitute t with 1. So, but we are told that our t is equal to 1 second. So we simply come and say, therefore, s, which is the distance, will be equal to 2. Our t is 1, so we have 1 squared plus our t, which is 1. So we end up getting 1 times 2, that is 2 plus 1. And we end up getting our distance as 3. And the units, we are told that the distance is meters, so the distance is 3 meters. So that's how we calculate the distance, or in our case, the displacement. We are calculating the distance or the displacement. So the distance will be 3 meters when t will be 1 second. Again, part B, when now t is equal to maybe 5 seconds. 5 seconds, and we need to calculate the distance. Because we have the equation for distance, we have already the equation for distance, we simply come and say distance is equal to 2t squared plus t. But we know that t is equal to 5 seconds, but t is equal to 5 seconds. So where we have t, we substitute with 5. So we are going to have that s therefore is equal to 2 into bracket t, which is 5 squared, then plus 5. So we'll end up getting 5 squared, that is 25, times 2 we have 50, plus 5 we get 55 meters. So that is the distance covered when the time is 5 seconds. And this is the distance covered when the time is 1 second. So that's how we calculate the distance or the displacement. You just need to have your equation for distance. Sometimes we may not have s. You may be told to consider a car moving at a distance h, maybe for a fixed point in time t seconds. And then you are given the equation now in the form of h. For example, you are given h is equal to 2t, maybe plus 3. And you are told that h is the distance. H is the distance. H is the distance. Therefore, it means that when you want to calculate the distance, for example, when time is equal to 1 second, you just come and substitute. Where we have t, you put 1. And then you'll be able to get the distance h. Because in our case, you are given the distance as h. Maybe you are given it in meters. So when you are told to calculate the displacement or the distance, you just require the equation for the distance. Then you substitute the values of t with the value that you are given for the time. And that's how we calculate the displacement. Then we are going to move on to calculation of velocity. Velocity. How we can calculate velocity. Calculation of velocity, that is as an application of differentiation. So I want us to look at how we can calculate velocity. And I would like us to consider this equation. Consider this equation so that you can get to know how we calculate the velocity by differentiation. So you consider an equation whereby distance, our s is the distance, is equal to 2t plus 2. 2t plus 2, whereby where this is a body moving, a body covering a distance s, where s is the distance, or we can call it the displacement, where s is the displacement in meters, and then t is the time in seconds. T is the time in seconds. Now I want us to use this equation. This is an equation of displacement, and we have time. We use this to calculate velocity. We use that equation to calculate the velocity. So in this, before we get even to differentiation, we know very well that when we plot a graph, when we have a graph of displacement, a graph of displacement against time, a graph of displacement against time, from your knowledge, previous knowledge in linear motion, for a graph of displacement against time, the slope gives us the velocity. The slope will give us the velocity. The slope or the gradient will give us the velocity. And we first want to confirm that and see which other way can we use to calculate velocity by now differentiation. So we simply move ahead and plot that graph. We can have like 4 points, whereby we have our equation s is equal to 2t plus 2. So we can have a table whereby we have time and we have the displacement, so that we can plot a displacement time graph. When time is, we can start with 0. When time is 1 second, 2, up to 3. So when t is 0, we are going to have 0 times 2, then plus 2. When t is 1, we have 2 plus 2, 4. When t is 2, we have 4 plus 2, 6. And when t is 3, we have 6 plus 2, that is 8. Then we can have the plot for that graph, our displacement time graph. Displacement time graph for that, we are going to have it this way. Displacement time graph. So we have on the y-axis, we have the displacement, and we have been given the displacement in meters. Then we have on this axis, we have time, and the time is in seconds. So we have time from 0 to 3, from 0 to 3 seconds. So we have 0 to 3. We have 1, 2, 3. So that's what we have. We have 0, 1, 2, 3, 4. Then we have the displacement. The lowest is 2 to 8. So we can have 2 to 8. So we have 0. We can have 4. We can have 6. Then we have 8. So in our case, we have 0. We can have in this 2. We can have 1 up to 8. So this is 1, we have 2, we have 3, we have 4, 5, 6, 7, 7 up to, let's say we have 8 there. Then we plot this point, we have 0, 2, then we have 1, 4, we have 1, 4. We want to see what the slope is going to give us, 1, 4. Then we have 2, 6, 2, 6, somewhere there. Then we have 3, 8. we have 3 and 8 somewhere there also. Then we can come and plot this graph. We plot the graph. So this is what we are going to have, and the equation is S is equal to 2t plus 2. That is the equation for our graph there. So in this, we want to get the slope of this graph, because we are saying that the slope of a velocity time graph will give us the velocity. So we get the slope, which is given by change in displacement divided by the change in time. So we get the slope, or the gradient, which is given by change in displacement, that is S, divided by change in time t. So we simply come and get some points here. Can come and get the points here that you want to use. We can use a point like 5. We can use a point like 5, or we can use the one that is already there. We can use these points for accuracy. Whereby we have 4, and we have 1. We have 4, 1. Then we can get another point. So we have 1, 4, 1. Then we can get another point. We can get a point like 7. In our case, we can take 7 and get the other point. We have 2.5, around 2.5. So we have 7 and we have around 2.5. So we want to get the slope. So we have here 4 is the displacement, so we interchange because we need to write them in x, y. So we have 1, 4, and then we have 2.57. So this is our x, y, and therefore the gradient will be given by the change in the displacement, which is on the y-axis, that is 7 minus 4, then divided by change in the x-axis, which is the change in the time axis, that is 2.5 minus 1. So we end up getting 3 divided by 1.5. 3 divided by 1.5. So when we divide 3 divided by 1.5, we end up getting our gradient as 2. The gradient is 2. So I want you to note that our gradient is equal to 2. And we have seen that on displacement, the graph for displacement against time, the gradient is equal to the velocity. And therefore, we can say from plotting the graph, therefore, the velocity is 2. On the y-axis, we have meters. On the x-axis, we have seconds. And therefore, it is 2 meters per second. That is the velocity. And I want us to consider the following. I want us to consider from our equation, I want us to differentiate that equation. Now, we differentiate the equation, differentiate with respect to t. Differentiate with respect to t. So in this case, we have our equation S is equal to 2t plus 2. And therefore, when we differentiate this, we are going to get ds all over dt, which will be equal to, we have here raised to power 1, so we have 1 times 2, that is 2. And then we have t raised to power 1 minus 1. Then we have plus, when we find the the gradient function of 2, which is a constant, is 0. So we are going to have 1 minus 1 is 0. A number raised to power 0 is 1. So our ds dt is also equal to 2. And therefore, you can see the velocity that we got here from this graph, that is after finding the gradient, is the same velocity that we are getting here when we differentiate this equation. And therefore, we can simply come and say, therefore, that when you want to get the velocity, it is simply differentiating this equation, that is the displacement, you differentiate with respect to time. And therefore, velocity is given by ds all over dt. You differentiate the equation of distance or the equation for displacement. So therefore, we can conclude and say velocity is equal to ds all over dt. That gives us the velocity. And we are able to see it from here, such that when we find the gradient of such a graph, a displacement time graph, it gives us 2. Again, when we differentiate the same equation, we get the same answer. And therefore, we can say velocity is the differentiation of this equation of distance. So velocity is ds all over dt. And we can do some examples on that for calculation of velocity. Examples for the calculation of velocity, and we have seen velocity will be given by ds dt. So examples. In the first question, in this, you are given the following. So number 1, the displacement s meters, covered by a moving particle, after time t seconds is given by the following equation, is given by s is equal to t cubed minus 2t squared plus t. And the question is, find its velocity. Number 1, find its velocity at 1, t is equal to 2 seconds. When t is equal to 2 seconds. And then number 2, t is equal to 5 seconds. So I want us to calculate the velocity for this. The displacement s meters covered by a moving particle after time t seconds is given by this equation. S is equal to t cubed minus 2t squared plus t. Find its velocity at t equal to 2 seconds and when t is equal to 5 seconds. So this is the equation for displacement s and the time t. So we want to get the velocity at time t is equal to 2 seconds. So solution for this, we want to first get the gradient function for this equation, which will give us the velocity. So when we want to get the velocity, we have seen is simply ds all over dt. So we are differentiating the equation with respect to t. So we have s is equal to t cubed minus 2t squared plus t. So we find ds all over dt. So this one will be 3 times 1, 3t. We have 3 minus 1. Then minus 2 times 2, that is 4. T squared minus 1. Then plus, here we have 1. 1 times 1, we have 1t, 1 minus 1. So we are going to have it as 3t squared minus 4t, then plus 1. That is our gradient function. So our v therefore is equal to 3t squared minus 4t plus 1. So now we want to find, this is the equation for velocity. Now when we want to find the velocity at the time t is equal to 2 seconds, we come and substitute the value of t with 2 seconds. And therefore velocity will be 3, our t is 2 and it is squared, minus 4, our t is 2, then plus 1. So we get the velocity as, this is 4 times 2, we have 12, minus 8, then we have plus 1. So that is what we have for the velocity. We get the gradient function, which is ds dt. Then that is the equation for velocity. After getting the equation for velocity, we now need to come and calculate that particular velocity when t is 2 seconds. And therefore we come and substitute the values of t with 2. So we are going to have, this is 4, then we have 5. And because we had meters, then we have seconds, so this is 5 meters per second. So our velocity at time t is equal to 2 seconds will be 5 meters per second. Again, we can answer part 2, the velocity when t is 5 seconds. Velocity when t is 5 seconds. So again, velocity is given by 3t squared, then minus 4t plus 1. In our case here, our t is equal to 5 seconds. So we substitute the value, we substitute t with the value of t, that is 5 seconds. So we are going to have therefore v is equal to 3. Our t is 5, so we have 5 squared minus 4. Here the value of t is 5, then plus 1. So we are going to have that as 25 times 3. We have it as 25 times 3, that is 75. So we'll have 75 minus 20, that is 4 times 5. Then we have plus 1. So we are going to have it as 56. Remember again, it is in meters per second. And that is the velocity when the time is equal to 5 seconds. And this is the velocity when the time is 2 seconds. So whenever you are calculating velocity and you have the equation for displacement or the distance, you differentiate with respect to time t. Then after differentiating, you will get now the equation for velocity. With the equation for velocity, you can calculate the velocity at any point. When t is 2 seconds, when t is 5 seconds, you are able to get the value for the velocity. Again, part B of that question, so the first one was finding the velocity at t is equal to 2 seconds and t is equal to 5 seconds. Then part B, this is A, part B of the question, find the velocity, that's the velocity, then find the time when the object, is at rest. When the object is at rest. Find the time when the object is at rest. Now, when the object is at rest, it is now at the turning point. If we were to plot this curve, it is at the turning point. And therefore, you should note clearly that when it is at rest, the gradient is equal to 0. At rest, the gradient is equal to 0. And in our case here, the gradient is the gradient of a graph, that is a displacement time graph, and therefore the gradient we said is equal to the velocity. Therefore, it means that velocity v is equal to 0. At rest, the velocity is equal to 0 because our gradient is equal to 0. And therefore, the velocity will also be equal to 0. Therefore, because we are told now to find the time, that time when the object is at rest, we need now to come and equate the equation for velocity with 0, because at rest the velocity is 0. So we have the equation v is equal to 3t squared minus 4t then plus 1. But our v at rest, v is equal to 0 because it is at rest. So we come and equate, then we find the value or the values of time t. So we simply equate that to 0. So we are going to have 3t squared then minus 4t plus 1 is equal to 0. So we need to solve this equation to get the values of t. And this is a quadratic equation. This is a quadratic equation where we have our a, b, and c. Therefore, we can use the formula for getting the roots. So we need to have, we have the sum. Our sum in this case is negative 4. And the product is 3a times c, which is 3 times 1. Then therefore the roots, we look for the numbers whereby their sum is negative 4 and then the product is 3. So we can have negative 1 and negative 3. Negative 1 times negative 3 is 3. Negative 1 plus negative 3 is negative 4. So we simply have 3t squared minus our 1 here minus 1t then minus 3t is 1, then we have plus 1 is equal to 0. This one you require the knowledge of solving quadratic equations. Solving quadratic equations, whereby we have various methods. We can have this for finding the roots. We can also have the formula method. So we have this. So we are going to factor out the common factor in this, and our common factor here is t. So here we remain with 3t, then minus 1. Then here we also factor out the common factor, which will in our case be, we have negative 1. Here we'll have 3t minus 1 is equal to 0. So you can see when we open this, it is this minus times minus, we have plus. So therefore, we have now to get the values of t. The first one will be given by t minus 1 is equal to 0. So our t is equal to 0. We take 1 to the other side plus 1. Our t is 1 second. Then with the other one, this and this are the same. So we use 1, whereby 3t is equal to minus 1 is equal to 0. Therefore, 3t will be 0 plus 1. 3t is 1. And therefore, t, we divide by 3 by 3, t will be equal to 1/3 seconds. And therefore, the time when the object is at rest, when the object is at rest is when the time is 1 second, and also when the time is 1/3 seconds. That is the time when the object is at rest. So that's how we get the solution for part B, time when the object is at rest. And we have seen that at rest the gradient is 0, and this gradient is giving us the velocity. Therefore the velocity is 0. So we equate the equation to 0 and get the value. It can be 1 or the values of t, and we end up getting in our case 1 second and 1/3 seconds. So in another case again, one may calculate the time, because most of them you'll find that you are getting a quadratic equation. Sometimes you may calculate the time and you get that, for example, time you get as maybe -1 second, and you get time again as 4 seconds. In such a case, you do not write the negative time. Time cannot be negative. Time can't be negative, cannot be negative. And therefore, you don't consider this one. You only consider, therefore, the time is equal to 4 seconds. At any case, when you calculate the time and get that it is negative, you don't consider that time because time cannot be negative. So our time will be 4 seconds. That is for time and also for distance. When you calculate the distance and get that it is negative, then you take the other that is positive because again distance cannot be negative. So in case you had calculated and gotten the two answers here as the values of t, after solving the quadratic equation, you don't consider t as -1. You just say that t therefore is equal to 4 seconds. I'd like to give you an exercise. To calculate displacement and velocity. So number 1, the displacement S meters covered by a moving body, after time t seconds, is given by the following. This is the equation, S is equal to 2t cubed plus 4t squared minus 8t plus 3. Find, this is now the question, find the velocity at Roman 1 t equal to 2 seconds, when t is equal to 2 seconds, and Roman 2 t is equal to 3 seconds. So you find the velocity at those points where t is 2 seconds and where t is 3 seconds. Again, part B of that question, after calculating the velocity at those instants, you also calculate part B, the instant at which the particle, in our case we have the body, instant at which this body is at rest. Then finally, question number 2. This is again on application of displacement and velocity, and application of differentiation in calculation of displacement and velocity. Here we have a particle moves along a straight line. In such that it moves in a straight line such that its displacement S meters from a given point is, we have been given the equation S is equal to t raised to power 4 plus 3t squared, then plus 4. And we know that where t is the time and S is the distance. So where t is time in seconds, So determine, the question is determine its displacement and velocity when Roman 1 t is equal to 0 and 2 t is equal to 4. So you calculate the displacement. In that case, the displacement and the velocity when t is 0 and when t is equal to 4 seconds. So in the next lesson, we'll be looking at how we can apply differentiation to calculate acceleration. So in our next topic, we'll be looking at now the calculation of acceleration, that is by application of differentiation. Thank you for being attentive.